My slides are visible. Am I audible?
Yes, sir, you are audible, sir.
Thanks. Thanks, ma'am. Should we start or wait for some time? Please.
2 minutes, sir. All
no
students
problem.
will join.
Yeah. No
Welcome
problem.
again, sir. Welcome to
Thank
our
you.
institute.
Thank you. Thank you.
Shri Devi, shall we start, ma?
Yes, ma'am. Yes, ma'am. Yeah, Rameshri, can you please start, ma'am?
Yes, ma'am. Good evening to all. It's a great pleasure for me to introduce our guest speaker today, who is talking to us about the introduction of data science. The topic is classification. He is the assistant professor of Department of Biotechnology Engineering, IIT Madras. He done his PhD in École Polytechnique Fédérale de Lausanne, Switzerland, and he has done many achievements in his career. Before the session starts, I would like to welcome all the staffs and students who are an important part of this session. I would like to request everyone to kindly cooperate with us throughout the program to make it wonderful. Last but not the least, I would like to request our guest speaker, Assistant Professor of Department of Biotechnology Engineering, Dr. Nirav Bhatt from IIT Madras. Welcome, sir.
Yeah, thank you, Ramya.
Yes, sir. I hope this session will be most informative and useful to all of us. Once again, welcome you, sir.
Yeah, thank you.
Thank you, sir.
So thank you, everyone. So I hope that Professor Arun Rajkumar had some discussion regarding what is regression, what is the classification, and what is in general data science, AI, and ML. I am going to talk about very briefly today classification problem and how it is different from regression problem. And we'll learn one or two techniques which are actually used in the classification, some idea behind them, maths a little bit. And during the tutorial, we'll learn some more classification techniques, how to use them for different kind of problems, which I think on handout session, Indumati will talk about it. Let me start today's discussion, and please feel free to stop me if you have an issue regarding what is topic about, or there are any questions. Do not hesitate. Please ask questions. You can ask in my Tamil is not that great, but I can still attempt. I can understand quite a bit, so you can ask in Tamil also, or other languages. I can try to answer in English, hopefully, so that you can understand what I'm talking about. So please do not hesitate to ask questions in a language which you are comfortable with. I can guarantee I can understand quite a bit of languages nowadays, so not a problem. So what is classification? So let's start with the linear regression, which you have studied last couple of lectures, where response Y is a quantitative. For example, if I want to predict given age, what is the height? Height is a number, which is a quantitative number, 120 centimeter, 130 centimeter, 140 centimeter, 150 centimeter, correct? Or 100 centimeters. Or let's say price of some clothes, it can be anything, correct? After GST, it can be any number completely. So there are quantitative terms where Y we want to predict are actually have some number in a real number, or sometime some problems complex also. But it typically real number, and many cases which we look at in practical, it is a typically positive real number. But think of scenarios where you do not need a complete quantitative information. Simple example I have listed here. The first one is fraudulent transactions of credit cards or even debit cards. So we use every now and then credit card and debit cards, and the companies which are actually providing these services of credit card and debit card want to ensure that if there is a fraudulent transactions, then they stop immediately that transaction. Now, discovering fraudulent transactions is a very challenging problem, because 90% of time you have used your card, or I have used my card to actually do a genuine transaction, correct? But someone will steal this information and perform the fraudulent transactions. Now, in this case, I give you a transactions, amount, location, and many other information associated with the transaction. And now what I'm interested in, given transaction is a genuine transaction or it is a fraudulent transaction. I want to distinguish between them. In that case, I'm not predicting a quantitative number Y for a Y, but predicting whether Y is a fraudulent, which typically denote as a 1, or Y is a genuine, we typically denote as a 0. So it's a 1-0 kind of a qualitative approach which we take in this kind of scenarios. Similarly, benign versus cancerous tumor. In a lot of application in the healthcare, this is one of the major application where people would like to figure out, given a tumor image, whether it is a benign tumor or it is a cancerous tumor. Again, I'm not interested in a volume of the tumor or those kind of things. I'm only interested in figuring out cancer, whether it is a cancerous tumor or benign tumor. Similarly, when we look at the product, we go out and buy all kind of things, buy pen, pencil, clothes, and there is some notion of quality we have in the mind, correct? Based on that, we decide to accept certain product and reject certain product. But when it comes to industry, they have actually have a far better uniform concept of quality. For example, if I want to buy some part for a refrigerator, so that part has a certain quality. If that part has to adhere certain quality standards, not only quality of individual, but quality of many agencies which actually approve that they are good quality products. In that case, the industry is interested in looking at the image of the product and say that whether this product is good to go, accepted quality, or it is, you can reject it. So in these three scenarios, whenever we look at the Y, which I want to predict, given the transactions detail of credit card or the image of mammogram or product image or any other information about product, we are interested in basically telling that Y is equal to 1, not acceptable, Y is equal to 0, acceptable, fraudulent, genuine, cancerous, benign. So here we are interested in the response variable being a qualitative in the nature, and we are interested in doing a task where we assign. So we are interested in basically classifying the data as a one sample or other sample. And that's what we are going to do in classification. Given the information, we want to say whether this information belongs to class 1, class 2, class 3. Okay. So what is classification in general? So we should not confuse ourselves. It's with the clustering. Clustering, we'll talk about it. It is unsupervised learning. Supervised learning, as Arun must have told you, that it is a learning where for each feature or each set of features, you have a label associated with it. Like in the classification, I tell you that, okay, in an example of what you call fraudulent transactions, I give you location, amount of transactions, what type of product is produced, product is actually not produced, acquired using that transaction, what kind of shops. Okay, these are the features of the transactions. And based on that, I want to tell that whether this transaction is genuine or not. Okay, so for example, in this case, I have given you, let's say the X1 is the location of the transaction and X2 is the product produced. Okay, and these are the transaction done by different individuals. Okay, and some of them are 0, which are genuine transaction, and some of them are not genuine. Okay, so why and what we are interested in a machine learning application is to find this line. Okay, you can see this line. And if I find this line using some model and using this data, when new data comes, I want to know whether it is a genuine or fraudulent. Now the question again comes is what does complexity in the classification mean? So the complexity we'll discuss in terms of how to actually create this boundary. If simple boundary will be a simple line, correct? But a complex boundary will be some curve. Here you can see it's a curve. So it tells you about complexity. Now the question is, what is the problem of using the regression approaches to classify? In terms of coding approaches for classification, it's not a problem. In other words, how you actually process the data is not a problem. But when it comes to assumptions, we have a lot of problems. So we will see what kind of problems we can arise into. Because typically regressions are based on certain models which want to predict quantitative terms. Of course, someone will say, I will predict the quantitative terms and then decide the boundary where, say, above certain number, it is class 1, below certain number, class 2, which can work. But sometimes for more than one class, it might be difficult to actually create such a boundary. More than 2 classes, it is very complex boundaries are simple coding is required, but through such that we can model complex boundaries. Complex boundaries is like more and more complex data here. And of course, we want to actually assign when we have multi-class problem, we have to be careful about how to actually assign, create those boundaries or create those demarcations. So that's why typically we use certain probability kind of approach to perform classification. So these are different techniques which classification classifiers, or which we call it classification techniques, which typically people use. One of the simplest one is the naive-Bayes classifiers, which we are going to discuss. There's a logistic classifier, linear or quadratic discriminant classifier, logistic regression sometimes, nearest neighbor classifier, perceptron, decision tree, and etc. etc. There are more classifiers out there. We are going to discuss some of these classifiers today. So we can start with the logistic regression. And here I am discussing a car brand, and we are seeing that whether it actually can pass crash test or not. So here you can see there is a car, and typically what they do is this car, they actually ramp into some object and take a video and see how the car is going to crash. Okay, and what kind of impact it will create in the seats. And based on that, there are certain criteria. Based on that, you actually say that, okay, particular brand model has cleared crash test or not. So in logistic regression, the input features can be both qualitative and the quantitative. So here, for example, you can actually have a quantitative features like how many number of people can see it, what is the weight of the car, what is the what you call it, engine cc, what is the bonnet area, anything. Another question you can ask is, which is qualitative, is in terms of it is a sedan or a hatchback, and blah blah blah. So both kind of input features we can give, and what we want to do is by using the past data before I go and crash the car. Crashing the car is not a what I call it cheap business. You actually have to take your product and crash it, and as a costlier the product, you want to ensure that you do not want to come back again. Otherwise, you have to, if it does not pass automatic crash testing, the product has to go back to the development. Again, you have to redesign it and bring back to crash it again. So you do not want to do that, okay? Because if you are making a product which is worth of 20-30 lakhs, coming back is a huge impact in terms of pricing and other aspect. So what company would like to do is they have a database which actually tells you some different input features like I described. And using that, they would like to know what will be likely outcome. Whether the particular car will pass the crash test or yes or no. And typically in a logistic regression or any other classification, we make it 1 or 0. Okay. Fine. Now let me talk about what is a logistic regression. Okay. And we'll see why regression cannot be applied. So here I have X, which is a feature, let's say weight of the car, and Y, which is basically telling me that whether the car cleared crash testing or not. If it's cleared crash testing, it is 0. If it's did not, it is 1. or the vice versa also possible. That's not an issue. How do you do encoding is not a problem. But right now, I have two encoding, yes, 0, no, 1. And this is for different model, we are showing yes and no. Now, if you use standard regression, what it will do is it will try to fit a best line here, which basically is trying to minimize distance between this one. Okay. But ideally, what kind of line we are interested in? Or model we are interested in? The model which actually gives us some kind of line in this direction, which is basically parallel to this line or x-axis. Because if I have such a line, then I can actually use this line and see whether the point is this side or other side when I get a feature x. If it's it is on top, I will say class 1, it's below that line, class 2. And where should I have that line is also an important part. So we'll see later on. Now, what we are saying is that instead of plotting 0, 1, why can't we plot the expected value of y given x, which is kind of some way you can think of getting you towards some kind of probability of given x, what is the possibility of y, whether it will take 0 value or 1 value. See, again, the question you will have, the expected value of y given x can be not between 0 and 1, it can be any value, correct, between infinite. So what we are going to do is, we call the expected value of y given x as a pi, okay, which is some number. And then someone say we can do pi 1 minus pi versus x. And the problem here is again is that in certain cases when pi is equal to 1, it can go to infinity, pi equal to 0, it goes to 0. So again, there is an issue. Then there is an issue about if you do log pi 1 minus pi against x, then again, this is an issue because there might be some negative value. So you see that each time when I try to do some feature, how I represent my feature with a different way, I get into trouble, which I do not want. Okay. So finally, if we do log pi versus 1 minus pi here, we can ensure that it will not go towards negative, or at least in most of the cases. So what we can do is we can actually plot log pi by 1 minus pi equal to b0 plus beta 1 x. So in that case, we can see that if you can do some simple linear algebra, you will realize that this pi of x will be nothing but exponential of beta 0 plus beta 1 x divided by 1 plus exponential of beta 0 plus beta 1 x. And the interesting fact here is, irrespective of x value here, this pi x will have a value between 0 and 1. And the interesting fact here again is that if I take this as a y and this as a b0 plus b1 x, then I have something like regression, correct? That's why it's called logistic regression, because it is kind of logistic function in some sense. So if I do that, I can actually, between probability p, which is nothing but pi 1 minus pi, and x, I can do that. And you remember that px unbounded below 0 and above 1, correct? Any probability by probability axiom as a 0 minimum, 1 maximum. Okay. And if we do log px equal to b0 plus beta 1x, it's only bounded on one side. So that is the interesting part. So if you take, this is the probability px, okay, and do this curve, then it will be like a start with 0 and it's a 1. Okay, which is my fx sigmoid curve. So with this px and this one as a, if you look at it, somehow if I take this term out, then it will be like a this term only, where the x is b0 plus b1x. Okay, somehow not little bit different than that, but more or less same. And the fx will behave like the what we are behaving here. This px and the fx are same with a minute change. Here we have a b0 and here there is no b0 here. Otherwise, it is the same. Since that's why what we can do is we can actually bound this particular term above by 1. So maximum 1 will be here and below by 0. And apparently this has come out as a one of the best model choice for many real life scenarios. And now we can actually, with this one, I can actually fit linear regression, and which I hope that you learned last time, and compute beta 0 and beta 1. Okay. Now we can also find parameter values in such a way that we can actually plug these values and get classification. So one way of formulating this classification is something called maximum likelihood function. You don't need to worry about it. I think ultimately when we do this way, it will be under certain assumption, will come to fitting a line with y equal to log px by 1 minus px equal to beta 0 plus beta 1 x is the feature. And you can do for multiple feature also. It will become multivariate line. And what will be my decision boundary? So some one way decision boundary can be if b0 plus b1x is non-negative, then we get p greater than 0.5 and y is equal to 1. Otherwise, we can get p less equal to 0.5 and y is equal to 0. And remember that if you do this way, logistic regression will gives you a linear classifier. Okay. Now, if you look at b0 plus b1x point of view, the decision boundary is the solution of equation, this equation. You can think about it sometime and get back to you. So sometimes decision boundary can be like this. So this is nothing but a set where both are becoming 0. 0.5, sorry, 0.5, not a 0. Why logistic regression people use? It is easy to interpret because you know probability, you know how the b0 and beta 1 actually contributes towards the prediction of px. So here you know that what is the contribution of b0, what is b1, and if you have multiple features, then you know what is the contribution of each of the feature when it comes to predicting the probability. And hence, the interpretability is easy. So if you know, let's say, for example, let me give an example, that the location, the contribution of location to find out whether the transaction is fraudulent or not, and contribution of amount to transaction is not, you might realize that the location has a more contribution on transactions than the amount. I might be traveling around the world and making transactions in several geographic areas, but my amount may not exceed certain value. I may do at max 30,000, 40,000 rupees. If someone does 1 lakh rupees, which I have never done it, it means there's a high probability this transaction can be fraudulent. Similarly, there's someone who is only living in Chennai and doing everything in Chennai, and suddenly someone buy some amount in Delhi, we realize that, oh, last 1,000 transactions in Chennai, suddenly one in Delhi, and that also very high amount This is outlier. This might be fraudulent transaction. So the contribution of these two can be very easily found out by examining beta 1, beta 2 when you have multiple features, which is one of the main advantage of logistic regression. Okay. Of course, another disadvantage is linear regression. It can be easily to extend it to the multiple classes, but in the many time people do not recommend that. But you can do it, not a problem if you are good at building a logistic regression. It often works surprisingly well as a classifier, especially for two classes. That's one of the main strong point of logistic regression around 8-10 years ago, when in a data science, logistic regression was one of the hot favorite method to apply for classification on a simple problem. Now it is deep learning, but earlier it was this kind of logistic regression, random forest kind of approaches. It provides best predictive model for the family of betting strategies and similar scenario with the diminishing return as a extremes. Yeah. So this is one advantage where it provides quite good prediction when you have a very poor, very diminishing returns at the extremes, means very small outliers. Okay, so that's why it provides a good results. So if you have any questions, I can answer before I go towards a second classifier. You can type your questions also. In chat, you can type. I think everyone can type, correct? Okay. If there are no questions, we'll move forward. So another one is naive-Bayes classifier. Let me ask many of you, how many of you know Bayes or Bayes theorem? You must have studied Bayes theorem, correct? In a high school or even college or during your studies, correct? So the naive-Bayes classifier is a classifier based on Bayes theorem. So let me go back to the same problem again. I have a set of class which is here denoted as in a red points, and there are some violet points, okay, which are another class. And here X and Y. Y is basically one feature, X is another feature. Okay. And what I'm interested in finding out this line, or in a general separating plane, which actually separates red from violet, correct? It's like like a wall around our house. We want to make a wall around this two classes. So this is your, basically, which you can think of, this is your house, this is your neighbor's house. And sometimes sometimes neighbors think he's also come to your house. Okay. Yeah, dog, for example, often my neighbor's dog comes to my house. That's it. Now, this boundary is the place where the probability of red class happening and probability of violet class happening is equal for a given feature. So this is the place where we don't know anything on this one, we don't know which belongs to our neighbor or to us. But anything this side and this side, it belongs to us. So, as I told you, there is a concept of conditional probability and the Bayes theorem. So let's visit that first before we go further. So what I'm interested in is finding out what is the probability of any class. It can be, or what is the probability of, let's say, red or orange, given the X. Here, X is basically two features. Let's say I give a feature of, let's example of the previous example we took of fraudulent classes, for fraudulent transactions in the credit card, where my objective is to find out whether given geographical location and the amount of transaction, what is whether the given transaction is fraudulent or genuine. So X1, X2 is the geographic location, amount of transactions, and I want to predict whether it is fraudulent or not. So I will say, let's say I want to only predict fraudulent, then in that case, I can use conditional probability, which is actually P X1, X2, given it is a red or fraudulent, into the probability of fraudulent transaction in general divided by probability of X1 and X2. Okay, so this is a conditional probability which we have learned in a high school. Now, what we can do is we can take the Bayes theorem, which actually depends on the conditional probability. And the Bayes theorem is very straightforward. What it says that, what is the probability? Okay, same is here. We are going to look at this. So it says something similar, that the probability of the red dot fraudulent transaction given X1, X2 is proportional to probability of X1, X2 given the fraudulent. So these two probability are more or less proportional to each other into probability of fraudulent transactions. And under the assumption of X1 and X2 are independent, it means that the geographic location and the amount are independent. So irrespective of you are not, it's not, it says that if you are in Chennai, you will not spend more. But if you go to Bombay, you spend more because Bombay is where people can spend a lot money. No, nothing like that. Both are independent. You can geographic location has nothing to do with how much you spend, because that's a one's characteristic rather than not location characteristic. Because both city has all kind of stores which we can buy. So spending has nothing to do with that. So that is called independence. So both are independent. Geographic location and your ability to, your habit of spending has nothing in a common. So in that case, P given P probability of X1 given the fraudulent transaction into probability of X2 given for fraudulent transaction will be given by this one. So this probability, when the X1 and X2 are independent, then we can write as a multiplication of each other. And this one is what is the interesting part in the Bayesian theorem. So if I want to find a probability of fraudulent transaction, like here I am interested in, then I need to find out what is the probability of the X1 given the fraudulent transaction into probability of X2 given fraudulent transaction into the probability of fraudulent transaction. Okay. Now, I'm going to take an example and explain this whole concept very clearly. So we'll take an example to understand Bayesian theorem where I have given you set of data, correct? So we have a Yamaha, Suzuki, TVS, Honda, okay, all these brands, okay. And we look at it whether it's repaired or not. Okay, just no. And this data, and last was injured or not injured. So this is the data collected on accident report with the status as a injured or not injured. And whether particular bike required a repairman or not. Okay. So there is possible that bike required repair but not injured. There is possible that no repair required at all, but person fell down and got injured. So there are all kind of possibilities are there. Four kind of possibilities are there. And this is the data. And the question I'm asking you that if I give a new data which says that Yamaha and not repair. So I'm giving you feature 1, which is telling you what is the bike type or what is the bike brand. And I'm also telling you that after accident, it does not require any repair. Then I want to predict whether the person is got injured or not. Okay. So that is a kind of a Bayesian approach where you recall the X1 here and X2 are feature. X1 is the Yamaha, X2 is whether it is repaired or not. And the prediction I'm looking for is whether the person riding this bike is injured or not after the accident. Right? So that is the whole idea of Bayes' theorem. Now, after that, let me give another example, which is a very, very simple example to understand classification, Naive-Bayes classification through Bayes' theorem. So I made a simple example rather than taking a previous example. We'll take a simple example where I have given you two kind of bikes, okay, Yamaha and Honda. That's a brand. And for each, Yamaha has a different bikes, okay. They have Honda also have different bikes. For example, Honda has an Activa and other kind of different kind of bikes. Yamaha has the same kind of different kind of vehicles. And each of these vehicle has a certain weight and the engine capacity. For example, here the weight is for example, first column or first row, which is the bike of Yamaha, where weight is 100 kg and engine is 300 cc. Okay. And vice versa for all of them, there is some weight and engine. Now, someone gave me a bike where weight is 85 kg and engine is 250 cc. Okay. But that person did not tell me whether it is a Yamaha bike or Honda bike. And he's a smart guy, he said, if you predict, bike is yours. Okay. So what I have to do is I have to use this data and somehow predict a bike is mine or not based on certain probability that given these two, weight as a 85 kg and engine is a 250, it belongs to which probability is higher. Now someone say, okay, let's look at the standard way and look at the probability of happening Yamaha bike and the Honda bike. And here, if you look at the probability that bike is Yamaha is also 0.5 because out of 8 options, 4 options are Yamaha, 4 options are Honda. So probability of Honda is equal to 0.5. So this will not help you to tell which bike is preferred. So I have to go back and do some more analysis and use Bayes' theorem. So with what assumptions we are making, the simple assumption I'm going to make, the features are independent given the class labels. Okay. Simple form of the probability distribution is followed by the features. Also, there is no necessary of linear hyperplane, and there are some mathematical things which you don't need to worry about, which we are needed. And one of the interesting aspect in the Bayes network is that it's so simple because it uses high school concept of Bayes' theorem, and it can be actually extended to the many features, and it provides a very great results. That's one of the advantage of Naive-Bayes theorem. So what we are going to do is we are going to predict this, okay, and it is using this data. So what I have done is I have taken this data, okay, and computed average Yamaha bike's weight and average engine cc, and I also computed variance. Okay, so I have computed mean for Yamaha bike, okay, for weight, mean for engine, and the variance for the weight and variance for the engine. And same thing I have repeated for Honda. Okay. Now, with this information, what I'm going to do is I'm going to use Bayes theorem under the assumption that all these are normal distributed. So I hope that you know what is normal distribution. Otherwise, Indumati will tell you how to actually generate the normal distribution in the Python. So here, as I told you, we are interested in finding out probability of Y given X, which is the weight and engine. So we want to compute this, and probability of Honda given weight and engine. Okay. So using Bayes theorem, if you look, remember, we use this one where we want to find out probability of X1 given it is Yamaha or the red dot into probability of X2 given red dot into probability of X1 red dot. So now what we are going to do is we are also interested in finding out that probability of weight as a feature given it is Yamaha, probability of engine given Y, and into probability of Yamaha, which we already know it is 0.5 from the data. But this probability, to find this probability, I have to use this mean variance and the assumption of Gaussian distribution. So Gaussian distribution is like this, is a normal distribution where what we are saying that given Yamaha, what is the probability X will take certain value. So now the X is here is weight. So what is the weight? Given it is Yamaha, what is the weight? What is the probability that weight is equal to 85? Similarly, I'm going to take what is the probability of engine is equal to 250 given it's Yamaha. And this quantity, I know what is the mean for weight, variance for the weight. So this is known for the when I want to compute this, okay, which is indirectly I want to compute this. Okay. So if I substitute all these quantities and 85, I can have a probability of weight is equal to 85 given it is Yamaha. Okay, that's what I have computed here by substituting here. Similarly, I have computed probability of engine is equal to 250 given it is Yamaha, which is 0.0970. Similarly, I have computed for the Honda, which is 0.026361 and 0.003925. So these two quantity are this one and this one. Now, if you compare, multiply here all this Py probability, this probability, and pH, this probability, which is basically multiplying these two into 0.5 and multiplying these two into 0.5, you can see very apparently that the probability of Yamaha given the weight is equal to 85 and engine is equal to 250 is higher than the probability of bike being Honda given weight is equal to 85 and engine is equal to 250. It means that if I predict that Yamaha, what my calculation says that, or new Bayes theorem says that my bike is high likely to be Yamaha, and I can predict Yamaha, and hopefully I can win my bike. So this is exactly what new Bayes does. It actually starts with a simple model and does the complex thing. So just to explain more formally, what we have is given a data point X with n features. So we have a set of data points, and for each feature, for each data point, we have a set of features. Like features are nothing but something which describe that particular class or that particular observation. So for example, in a case of fraudulent versus non-fraudulent, we have features like geographical location, amount, kind of product, etc., etc. Okay, and in a larger case, you have K levels. In a K levels, it's not only fraudulent versus non-fraudulent, but if you sometime what some problems has a you want to know grade of product or grade of disease. Okay, it is for example, in a cancer, we are interested in is a particular tumor is benign tumor or primary cancer tumor or metastasis cancer tumor. So there are 3 grades. Okay, because it depends on that the treatment changes if it is either one of the grade when it's a cancer. So that might be sometimes the cake labels are different grade are possible. And what we are interested in finding the probability of given class K given all these X features. And the solution is simple using Bayesian theorem, where every time you compute Bayesian theorem, of course, how you can do it by training it and finding this probability of CK, probability of X given CK, and this probability. So I'm not going to go into detail, but just to how to actually handle some of the problems. For example, when events model is discrete, in that also you can actually use standard tools to actually solve the problem. So even you have a discrete features, you do not need to worry about. When you have an event model is continuous, you can simply compute the mean and variance features and fit simple continuous model like Gaussian Naive model, multinomial Naive Bayes, Bernoulli Naive Bayes, etc. So basically, it is nothing but here I am assuming all the variables are continuous and Gaussian. Here I am assuming it is a multinomial Gaussians, multinomial distribution. Here I am assuming Bernoulli distribution. Okay. And let me go towards last method very quickly in 5 minutes, and then I'll open for the question answer. If you have any questions, you let me know. Otherwise, in 5 minutes, let me explain this. This is another simplest method, which is called nearest neighbor. It's called K nearest neighbor. The assumption is simple: small region has the same label. Okay, think this way that I actually take a set of people from first year BSc and set of people from last year MSc. Okay, they might have different features, correct? People or in IIT we have schools also. So I'll take a student who are in a 5th standard, and I'll take a student who is in a 4th year of BTech. Now, based on the features like height, weight, body mass index, I will actually segregate people. It is most likely that the 5th year of 5th standard kid would have a more or less similar body mass index, height, weight, and similarly the 4th year BTech students have a same kind of features. Okay, so the whole idea of nearest neighbor is then some new person comes. Let's say I don't know. I'm a let's say blind person, and try to understand that this new person. Someone will come and tell me this person has this X weight, Y height, and this is the body mass index. And what I'll do is I will go and look at the body mass index of the 4th year, these 3 features for the 4th year students and the 5th standard students, and based on there, I'll decide which are the near one. The person who actually is a similar third year would be more likely to go to the group of the 4th year of students rather than 5th standard kids, correct? And if someone is near to the 3rd standard or the 4th standard or 6th standard, they will go towards 5th standard school kid. So this is the whole idea of nearest neighbor. when I put the point, what are my neighbors, and based on that, I will decide whether I belongs to this class or other class. And that's what is the idea of nearest neighbor. And the K is the one which how many points I should select, how many neighbors I should do. Only 1 is enough, 2 is enough, 3 is enough. And based on that, you can actually create a different thing. Okay. So K nearest classifier. This is the new kid. And we have to tell that whether this kid belongs to the school here, this class, or it belongs to this class. And what I'm going to do is, with the 3 neighbors, I can say that it is high likely to be in the class which has a red color. With the 4 neighbor, I have a tie. I can't decide. With the 5 neighbor, I might tell that this is this one. So you can depending on the K, neighbor might change, and finding a K is a kind of what you call tuning parameters, which you have to tune to figure it out. So if I take a 2, 3, this is I can keep doing it, and I can create this line between these 2 points, and then new person comes, I will look at whether it's this side of line or other side of line. Okay. So why K nearest neighbor classifier is useful? It is a non-parametric method used for classification. There is no model involved, no Bayesian model, no linear model, nothing. But it is a lazy learning algorithm. Why? Because all the computation is deferred until the classification. You are not building a classification first and doing the things. You are actually finding the instance and then running the algorithm and basically describing where the person belongs to, right? It is also called sometimes instant-based learning, because where the function is approximated locally. Why? We decide this boundary based on the local approximation. Here also, if I am here, this is the point. I will look at the 3 neighbor and say that, okay, locally, these are the red. That's why. That's why it is called local. Why KNN? Simplest of all the classification algorithms and easy to implement. There is no explicit training phase and does not do any generalization of the training data. That is a good idea. When to use it? When there are nonlinear decision boundary between classes, and when you have a large amount of data, then you can use KNN. Okay. Input features can be both quantitative and qualitative. It does not discriminate between those kind of features. So you can have a quantitative features like height, weight. Okay, qualitative feature like a male, female. Okay, where you have described, or tall, short, those kind of features. The output can be our categorical variable. Basically, it is a which class, whether it is a class 1, class 2, class 0, or 0 and 1 in a binary classification. And typically what you do is majority vote. What is majority vote? Remember here, when I had a point here, the 3 neighbors were in which I have 2 were red and 1 was violet. So out of, when I do majority voting, what is the majority? Red. So I have actually voted it as a red class. But if I do 4, it is a tie. So I will say it is a non-classified problem. We'll worry about it later. Let's continue with another problem. So point. Several assumptions is made. Since I don't have much time, I am not going to discuss about it. So how you actually decide the proximity between 2 points. So there are different kind of Euclidean measures are there. Mahalanobis measure, there, Hamming distances there. So there are different distances people use, which are many mathematicians has actually discovered depending on the data, as well as depending on what kind of problem you are solving. You can use Euclidean, Mahalanobis, or Hamming distance. The algorithm is simple. Compute the distance metric between the test data and all the labeled data point. Order the labeled data point in an increasing order of this distance metrics. So the first data points talks about nearest point, the last one are the farthest one. Select the top K label data point. So first K, so K is, they say 10. So I will look at first 10 data points and put their labels. Okay, whether it is belongs to class 1 or class 0, and then I will find out which is the majority class. I will do majority voting and find the class that the majority of this K label data points have, and assign the new data or test data point that particular class. That's a very simple. So illustration here is a class 1, class 2, K is equal to 3. So here in this one it is 3. So I found out this is a class 1. Here is the class red. It is class 2. Class 2. Here it is class 1, depending on the majority. If you have 5, it is a different possibilities. Okay. And the thing to consider here is parameter selection, how many K you should select. Okay. Presence of noise. So sometime some small measurement in height and weight can create an issue. So you have to be selective. Feature selection and scaling. So sometimes you have to scale because if you do not do it, when you measure something using the Euclidean distance, you might need to, some feature you give more important than the other one. And the curse of dimensionality, we will discuss maybe on Friday about it, which unsupervised learning, how to handle that. Okay, so I'll stop here. There are other aspects are there, which I don't want to continue with that. Let me conclude here. If you have, I'll share notes with you, and you look at it, what is happening, because it's not much difficult to understand. For example, here, if you look at it, if I do only one neighbor, I get so many small island, and if I do 15 neighbors, I get a very smooth boundary. So I have to see whether whether I want small island, which is not a good classifier, while the smooth boundary is a decent classifier. So let me conclude today's talk and give us some time to have one or two questions. So classification is an important class of problem in machine learning and AI. Most of the work we see is nowadays is in classification and quite a bit in regression. The objective of classifier is to find a class boundary for a binary classifier, and same with something similar to boundary equivalent for a multi-class problem. There is a linear classifier as well as nonlinear classifiers. Logistic regression, naive-Bayes regression, KNN are some of the simple classifiers. Perceptron, support vector machine, neural networks, and now deep learning-based classifiers are a different kind of classifier. With this, I would like to stop now, and I would request you that if you have any questions, please ask or type in chat box. No questions? Someone has the question, I guess. Or they can raise their hands. If there are no questions, then there are. Okay. If there are no questions, then we can meet on Friday, 4:30, correct? Fine then. Thank you. Have a nice evening. I'll see you in 4:30, and we'll have a discussion on and some introduction to unsupervised learning techniques. Okay. Have a nice day.
Thanks a lot, sir. Wonderful lecture we had.
Thank you. Thank you, ma'am. Thank you. Have a nice evening. Bye-bye.